Hello everyone. In this video, we will be learning circle properties. So before we move on to the properties, let's learn a few concepts. The first one is of a diameter. A diameter is a line that divides the circle into equal halves crossing from the center. A radius is a line from the center to the circumference. A chord divides the circle into two parts, so you can also say that your diameter is also a chord. Now let's move on to the properties. The first property that we'll be doing is of a chord. So let's make a chord here. This is a chord and this is my center. So when I make a line from the center to the chord, then that would be making a 90-degree over here. And it would be dividing my chord into two parts. So I can also say that this line is bisecting my chord. Now, similarly, if I move on with the same property, then there are lots of things that I can deduce. For example, I can say that if this is my chord and this is the center and it was meeting like this. Now, if I make a line in the similar way, now what is this line called? This line is called a radius. Why? Because you can see that it's starting from the center and moving to the circumference. Hence, it is my radius. So if this is my radius, then this is also my radius. So how about we say that this is an isosceles triangle because two sides are same. If this is an isosceles triangle, so this angle over here and this angle over here would be my base angle. So if let's say if this is 20 degrees, so this would also be 20 degrees. And automatically I can find this too. 20 plus 20 is 40. 180 minus 40 is 140. So I found this angle as well. Okay, let's move on to the next property. The next property is where a chord is, let's say, of 10 centimeters and it's meeting the center like this. Now, if there's another chord of 10 centimeters like this and it's also meeting the center, then I can say that these two chords are of the same length and the distance of the center would also be same. So these all are of same length. Then the next property is of the segments. What are segments? Do you remember what segments are? Segments are where this circle is divided into two parts. So let's suppose this is a segment over here. This is a segment and this is my segment. So these are the two starting and ending points. Now what you need to note over here is the starting and the ending points. These are the 2 points from which this segment is made. Now if I make one more segment from the same line, then let's say it's like this. So I can say that these two angles over here are of the same measurement. If this is 20 degrees, then that would be 20 degrees as well. So if this is A, then this is also A degrees. Why? Because these are angles in the same segment. Angles in the same segment. I will be later on putting on a post where I would be writing down all the theories behind it. So I hope you'll be checking it out. Okay, then the other property is of the angles in the segment and the angle at the center. So let's say this is a segment over here and this is my center. So if this angle is A, then this angle would be 2A. The reason is that the angle at the center is twice the angle at the circumference. So for example, if this is 10 degrees, then this would be 20 degrees. Or if you have this as 40 degrees, then you can automatically say that this angle over here is 40 divided by 2, which is 20 degrees. Now, from here, I can take out one more property. The property is that, for example, you have the center, which is like this, and you have a point on the circumference like this. Now, if the question has asked you to find this angle, then please know that the corresponding angle or at the center would be this one. So for example, let's say the question gives you this angle. The question gives you this as 100 degrees and you have to find this, which is x. So what you'll be doing is you will be finding this angle over here first, which will be 100 minus 360, which is 260 degrees. Now this angle and this one, these are corresponding. So 260 divided by 2 is equals to 130 degrees. So x is 130 degrees. Okay, the next property says that a cyclic quadrilateral, what is a cyclic quadrilateral? A cyclic quadrilateral is one where all the corners of the quadrilateral touch the circumference like this. You can see that all the corners of the circumference are all the corners of the quadrilateral are touching the circumference. Now, about this, the opposite angles at the in the quadrilateral would be equal to 180 degrees. If this is A and this is B, so A plus B will be equals to 180 degrees. Let's suppose a value. For example, this is 70 degrees. 180 minus 70 is 110. So this angle would be 110 degrees. The only thing that you have to notice over here is that all the corners, all the vertices are meeting the circumference. For example, do not be confused if this is your question and your quadrilateral is like this. Then you can see that all the corners are not meeting. These 2 points are not meeting the circumference. Hence, this will not be a cyclic quadrilateral. Now, the next property over here is of a tangent. What is a tangent? A tangent is a point which cuts the circle at exactly one point. So let's say this is my radius and there's a line from the radius to this is my radius, right? And now I'm going to make a tangent from the radius. So this is my tangent. You can see that it's meeting at this point. Now this point is going to be a 90 degree. Sorry, this point is going to be a 90 degrees. So wherever the tangent meets the radius, it's going to make a 90 degree at that point. From the same property, I can find one more property. That property is that if I add these two properties like this, for example, this is my circle and this was my radius, and this was my tangent. Let's say I have one more similar property. This is my radius and this is my tangent. So when these two are going to meet, they're going to meet at an external point. So this point is going to make a kite. You can look at it and let's see where the 90 degrees are. This is a 90 degree. This is also a 90 degree. It's a little bit shaky, but I hope you agree with me. So this is a kite. What are the properties of a kite? A kite says that two sides, adjacent sides are equal. So these two are equal and hence these two are equal as well. And if I divide this into half, let's say I'm dividing it into half. So what's happening over here? Now this angle and this angle over here have been bisected by this line. So if this was total 60 degrees, let's say this was total 60 degrees. Now this is 30 and this is 30 as well. And if this was, let's say something A, then this is A as well, because these two would be of the same measurements. Now there's one more thing. This angle and this angle would add up to 180 degrees. So let's say in this case, 30 and 30 add up to 60. If this angle is 60 degrees, then 60 minus 180 is 120. So this angle is 120. So just do some calculation. If this total is 120, then what is this part? 120 divided by 2 is 60 degrees. So this angle would be 60 degrees. Similarly, this would be 60 degrees as well. If you want to check your answer, you can see that it's a right angle triangle. 60 plus 30 plus 90 add up to 180 degrees. So there you go. Okay, and now the last property that we have is of a diameter. I find this really easy, this one. So the property is that if this is a diameter, what is a diameter? Quickly think. A diameter is a line that passes from your center. This is how you will be identifying your diameter. So if the diameter is meeting the circumference at any point in the circumference, so it's going to make a 90 degree. Wherever it meets, it's going to make a 90 degree. Whether it meets here, whether it meets here, anywhere on the circumference, it's going to make a 90 degree. I find this really easy. Now let's move on to some questions. The first question, these are all past paper questions. The first question says, find ABD. So ABD, let's point it out. ABD is over here. Now think about it. This angle is in a segment, which is this one. These are the starting and the ending points. And these are making one more segment, which is 34. So if this is 34, that means this would automatically be 34. Why? Because these are angles in the same segment like this, 34, 34. Hence, this is 34. If the question asks you what property are you using, you're supposed to say angles in the same segment. Next part, AOD. AOD, where is it? AOD, AOD. Okay, so we just found out this angle which was 34 degrees. If this is 34 degrees, this is at the circumference. What will be at the center? Angle at the center is twice the angle at the circumference. So 34 times 2 is 68 degrees. So this would be 68 degrees. I'm writing it down so that I know all the things that I've found out. The next question says, find DAB. Where is DAB? DAB is over here. Okay, this is not a right angle triangle, so please try not to find some stupid conclusions on your own. We have to find this angle over here. What do we do? If this is 69, that means this angle over here will be 69 as well. So let's write 69 over here. This total angle is 69 degrees. Now I'm looking at this triangle. I'll just highlight it for you so that you are with me. This angle is summing up to 180 degrees. I have 69, I have 34. So 69 plus 34 minus 180 degrees is going to give you the angle which will be 77 degrees. Let's move on to the next one. The next one says find x. Okay, so x is over here. This is x. And I have this 53 over here. This is the only angle that I know. So definitely I have to use this. Just look at this thing. Look at this triangle. Focus on this. What is this triangle? This is an isosceles triangle. Why? Because these are this is my radius. This is my radius. Definitely is going to make an isosceles triangle. This is 53. Hence, this is also 53. So 53 plus 53 is going to be equals to x. This is the exterior angle property that I'm applying. So 53 plus 53 is 106 degrees, which will be equals to x. So x is 106 degrees. Find y. Okay, can you relate to it? We've done this already. This is the center, this is the circumference. Angles at the center are twice the angle at the circumference, but only the corresponding angles. Y and X are not at all related. So what we'll be doing is we will be finding this angle first, and then let's find it out first. So 360 minus 106 is 254 degrees. 254 degrees. So this angle is 254. 254 divided by 2. 254 divided by 2 is 127. So this y over here is 127 degrees. 127 degrees. Why did I half it? Because angle at the center is twice the angle at the circumference. Remember this mantra. Okay, find z. Z is over here. So simple. So this is a right angle triangle. How do I know? This is my center. This is the diameter. Diameter makes a 90 degree at the circumference. So this is my 90 degree. All right, if this is my 90 degree and I need to find Z, so what I'll be doing is that first of all, see that this is a Z. If this is 53 degrees, then this is automatically 53 degrees. We did not even have to do anything in this one. Find T. Now we will be using the 90 degree that we just made. So this is a 90 degree. We have Z, which is 53 degrees. 53 plus 90 plus T is equals to 180 degrees. And hence T is equals to 37 degrees. I'll just write it down. 90 minus 53 is equals to 37. This is how I calculated it. Okay, the last one. Find EAD. Where is EAD? Okay, EAD. Basically find this angle, right? All right, again, an isosceles triangle. I love isosceles triangles. If this is isosceles triangle, that means these two are my base angles, which will be same. So I prefer using the exterior angles property because it makes everything so simple and it's just for 1 mark. So I'm going to use that. Otherwise, what you can do is find this, subtract it from 180, divided by 2 in order to find this. But I'm not using that. I'm just going to divide 138 by 2 because the sum of these two is equals to 138. So 138 plus x is equals to 180 degrees, and hence you can find it out. So 138 divided by 2 is equals to 69 degrees, and 69 is your answer. Okay, find EAF. EAF is over here. Here. This is the angle that you have to find. All right, this is very simple. How? This is your radius and this is your tangent. Hence, this is a 90 degree. So you just found out this, which is 69. 69 minus 90 is going to give you 21 degrees, and 21 degrees is your final answer. Find BEA. Where is BEA? BEA. They're asking you to find this angle over here, this angle over here. I'm highlighting it, this angle. So the total would be 69. 69 minus 12 is 69. Let me do the working. Minus 12 is equals to 57 degrees. So hence this is 57 degrees. Find BCD. Let's see where it is. BCD. And this is for 2 marks, I guess. Yeah. So you have to do a little bit more working. What you can do is first figure out where it is. It is over here. Over here. This is what you have to find out. And I'm just trying to figure out which property I can use. This is not a segment because obviously I don't have any other ending point. Let's say if this is a segment, then there's no other segment being made. What do I do now? I don't have any center. I don't have anything. So basically what I'm trying to do is I'm going to figure out what is this shape. This is a quadrilateral. Do you remember the property of cyclic quadrilateral where the opposite angles add up to 180 degrees? So this angle over here will be opposite to this angle, but I don't have this angle. That's the problem. So what I'm going to do is I'm going to figure out any other thing. Okay. This is a 90 degree. This is a diameter. So this is definitely a 90 degree over here. Let's make a 90 degree here. This here is 90 degree. If in any way I find this angle out, I can find this out as well. So how do I find this? Now, just see how I can find this. Basically, this is a segment and this is the same segment. So the angle that we just found out, which is 57 degrees, is also 57 degrees over here. If this is 57, this is 90, then this will be 90 minus 57, which is 33 degrees. 33 degrees. Now I found it out, opposite, opposite. So 180 minus 33, 180 minus 33 is equals to 147. So therefore 147 is your answer. Okay, so that's it. And let me know if you need any other help, and I'm there to help you. Thank you very much.